Hello class, so welcome back to the next lab, Advanced Machine Learning Techniques. So in this lecture, in this lecture lab, we're gonna talk about some of the strategies that we talked about lecture. That includes scaling, feature encoding. We're gonna talk about the how can we apply k-fold cross-validation, and investigate regularization. So the goals for the by the end of this lab, you will be able to scale data using the sklearn standard scaler normalizer, which is the two that we talked about in the PowerPoint. And we're gonna encode categorical data using ordinary encoding, one-hot encoding, and dummy variable encoding. We talked about those three different methods, meaning that this assigns a numerical value to columns, features columns, right, that have strings, text, and gives them a number. The one-hot encoding, practically what it does, it creates and also the dummy variable encoding. Practically what it does, it creates a new column for every single uh, text value that you have on the feature. So let's say you have a feature that is the color of the hair. So we might have blonde, red, brown, and black. And so so in this case, it will create a new feature for each of those those options classifications. So and then it would assign a 1 0 0 0 1 or 0 1 1 0 depending on what the value is. So it's gonna give them like a binary number. And the same thing with the dummy variable coding is just with one less feature. We're gonna be able to use some evaluator models' ability to handle unseen data by using the k-fold cross-validation. So practically what we're doing is we're applying some of the advanced techniques for machine learning. We're gonna practice it on the logistic regression and the k nearest neighbor. So on the first one, we already kind of give you guys the import, so you don't have to worry about it. But here we're gonna have some of the common ones: pandas, numpy, matplot to graph the sklearn, to be able to import some of these normalizers, encoders, and then some of the to be able to split our data, the k-fold. And then we're going to be able to import also some of the models, logistic regression, k nearest neighbor, and some of the metrics to be able to evaluate our performance. So we're going to be extracting some data, and here's the URL that we're going to extract the data from. So and then we're turning that URL, we're reading that CSV file, turning it into a data frame, and then we're just gonna print the first 5 of them. So I'm gonna run this code right here so you guys can see, and then so that we can import the files, and then we're gonna be able to print the top 5 rows of our data. So now you can see here. So you can see here that we have nitrogen, phosphorus, potassium, temperature, humidity, pH, rainfall, and crop, right? So you see here we have the classification, rice, and some other options, right? So what we're gonna do here is we're gonna extract the features from the data frame and the label. So we practically want the nitrogen, phosphorus, potassium, temperature, humidity, pH, and rainfall to be part of the features, and the crop will be our label. So that's the instructions that we want to assign here. So in order to be able to do that, we want to practically just drop the crop from the columns. We just want to drop the crop, and that's the easiest, the fastest way to just create a data frame that only includes everything except the crop. And this technically doesn't modify the data frame, but makes a copy of it. If you want to be able to make a copy, you have to make it, you have to choose to be true. And then the label, we're just gonna grab the crop. So then we check here, and that worked. Now what we're gonna do here is we're gonna separate our training data and our test data. We're gonna use the 20%. So we're gonna use the train underscore test split. We're gonna import our features, so that's our features there. The next option will be for our next attribute will be for our label. Our test size, we want that to be 20%. So we're gonna do 0.2, and then random state. So the random state is for us to keep having the same consistent answer. We can remove that, and that would give us a random solution every single time. And then we want to standardize the training and testing data using the scalearns data standard scalar. So remember that standardizing means that we're going to take the data's values and we're going to make them within the range of -1 and 1. So we're going to standardize our data. So we're going to standardize it. We're going to use, so we're going to create this object standard scalar. We're going to apply this standard scalar to fit the data transformation of our X trained. So what we're doing is we're training our data to be within the range. So it has to find some standard deviations and mean to be able to put it within the range. And then we're going to use the same one to be able to fit the data of our test. So we're going to do the same thing, transform. And there you go. We have standardized our data. We're going to do the same thing for we're going to normalize our data as well. So we're going to do fit transform. And we're going to pass in our data train. So remember, this is the train that was split from X train values that was split from our features. 80% of the data, and 20% of the data is going to the from the features data is going to the test. And then here we're gonna do a transform X test. So we have standardized it and normalized. This is practically all you need to do when you normalize and standardize the data. Now in the next part, we're gonna compare the standardization and the non-standardization, so the original data that has not been standardized with the data that has been standardized. And we're gonna do that for one specific feature. We're gonna do it for the unscaled feature 0, and we're gonna compare with the standardized feature of 0. We're gonna compare both of them, and we're gonna graph them. So right now, I already did that for you guys. So you can see here that we're comparing the values with each other. So you can see how on the left side it has been standardized. Well, the values goes from 0 to 140. We're gonna do the same thing for the original data with the normalize. So we're gonna change this to normalize. We're gonna change this to norm. And this is going to be normalize. Normalize. So again, we're taking the inputs of the train, untrained data and the normalized data. We want them to be the same size, and we're going to compare them in the graph. And now we're going to do the same thing with the normalized and standardized data. So we're going to have our standardized data and we're going to compare it to the normalized data. And this is going to be standardized, and normalized. Standardized and normalized. And now we graph them. We can compare up method. I think I missed something. Scatter. Oh, I put a, it's supposed to be underscore there. There you go. Good. So then the next couple of questions, what we're going to be doing is we're going to be applying this original data that is not scale and standardized data and normalized data with the test set. We're going to compare the results and how they perform using a logistic regression model. So we're going to use a logistic regression model, and we're going to apply it with the original data, that means on scale data, and then we're going to do it also with the standardized and then normalized and see how they apply. We're going to compare them. We're going to compare their classification report and the confusion matrix. So they're practically going to be almost the same thing. So right now we're going to use the logistic regression model. So we're going to create an object of the logistic model. We're going to train our data to this model. So we're going to use the untrained data. So this is practically the data that hasn't been normalized. And then what we're going to do is we're going to find the prediction for our data, for our test data. And oops, I think I deleted the predict. And then we're going to use that predict on scale data. We're going to compare it with the actual value that it's supposed to be. And then within the same model. And then we're going to see how they perform. So we can see here the values for each prediction for the apples with the prediction recall F1 score. And then for the bananas and everything. So you can see the accuracy prediction for every single class. So here we actually doing more classifications. We're not just doing a binary classification. It's either a dog or not a dog, or a dog versus a cat. This is actually we're doing a prediction or training of multiple classification labels. And they can do also accuracy, compare the averages of all the values there. So you can see a macro average, it has a 94% accuracy and 95% precision is 94%, recall is 95%, and a 94% of F1 score. And we're gonna do the same thing for we're gonna do now the confusion matrix, so it's already set up for you guys. Again, so we're creating a confusion matrix, we're passing in the actual result, the answer with the predictions that we have made. We're gonna use the model, the logistic model that we use, and we're gonna create a confusion matrix for that CM, for that confusion matrix, and we're gonna graph it. So you can see here how many predictions were done correctly for apple, how many were correctly for banana, black gram, chickpea, coconut, so on. You can see here that the maize had some trouble, right? It was the true value was 4, but it was predicted as a cotton. So you can see that in here, in this case, there was some error with the prediction of a big error predicting our a maize. And the same thing happened with the black gram and the monthlies. Okay, and then those were the biggest problems that we saw. when it's not normalized or standardized, sorry, or normalized either. So now what we're gonna do is we're gonna use the logistic regression with the standardized training data and test and on the set test using the classification report. So we're gonna apply now the logistic regression again. We're gonna create a new logistic regression, and then we're gonna pass in the data that we want to train on it. In this case, the train is the one that we standardize, the train standardized data, and we're gonna compare it to our train labels. We're gonna do some predictions, like the same way we did before. We're gonna use the model underscore st, right, for the standardized, and we're gonna make a prediction for from our x test underscore std, and then we're gonna create our classification report. So in our classification report, we need our y test result, our prediction standardized. So we're gonna compare our y test and our prediction standardized values, and our labels will be from the model of our standardized values classes. And we'll run this, see if that runs. Oops, I think I'm missing an underscore and another parentheses. All right, so we can see here the precision recall F1 score for every single fruit in here. So we can see that on average, the macro average precision was 96, recall was 97, and then the F1 score was F1. It was one score. It was for the M1 score, it was 96. So you can see if we compare it to the one before, we had a 94 for the F1 score. So we had definitely an improvement of 2% in our predictions. So that's pretty good. And then we're gonna do the confusion matrix for this one as well. So we're gonna, I'm just gonna copy and paste from the other one. So I'm just gonna copy this. And it's not gonna be the prediction on scale, it will be the prediction STD. The model will be not the on scale one, but the S standardized one. The confusion matrix will be on the display levels will be equal to the model underscore standardized class underscore parentheses. So we're gonna apply our confusion matrix on our our confusion matrix display using our confusion matrix that we just created over here. That is comparing the y test and the prediction values. We're gonna graph it and see. Oops. Classes. Sorry, I forgot to put classes there. It's plural. And now we can see our predictions. It's a little bit better, yeah, right? We don't see that many actually wrong solutions other than the jute and the rice. Those ones I think is the only one that where we actually have a wrong prediction. It was supposed to be rice, but it predicted jute, and everything else is very, very good actually. So that's actually a pretty good setup. So it seems like our standardized was a success. And now what we're gonna do the same thing, but we're gonna do it with a logistic. With the normalized logistic regression. So it's super easy to normalize or standardize our data. And so, oops, I'm just gonna copy the other one and change the values. So now we're gonna do it on the norm, and our y train still stays the same. This is going to be norm, though our x test will be norm, and our prediction will be norm, 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 and I think that covers all. Oh, one more right here, norm. So we're creating the logistic regression model. We're gonna train on our model. So we're gonna, when we say the word fit, is because we're training it. We're training on this value. So this is our, what is supposed, this is our data that we're gonna use as an input. This is supposed to be our output, and we're gonna train it. It's gonna be modifying. We're gonna make sure that it creates the weight values for that. And then this is also norm. We're gonna make a prediction using our model to predict our test. What's gonna be the prediction label for our X test? And then we're gonna use that to compare it to the actual value, which is the Y test. And we're gonna see what we get. So we see here that it's actually a little bit worse. On average, it's an 84% accuracy prediction, 84% recall, and 80% one score. So it seems like our standardized was actually a pretty good one. Our standardized values, we had a pretty good value there, 96. Now what we wanted to do is we're going to create a confusion matrix to be able to analyze our predictions as well. So in this case, we're going to have prediction norm, model norm, yep, it seems like that's the only one. And then we can see our confusion matrix. So you can see here, you can see a lot more. Oh, sorry, that's a big one. A lot more incorrect predictions. A lot more. So it seems like our normalized was not a success. We even have 9 wrong ones there. Very big unpredictions. So as you can see, our normalized was not a good. It didn't help us. Which of the 3 models had the highest performance? We said that the standardized had the best performance. Which one of the 3 models had the worst performance? We said that the normalized had the worst performance. For the highest performing model, what 2 classes did struggle the most according to the F1 score? The for the highest performing model, we said that the Rice and the Jude had the most struggling one. And then the other question is, using coefficient measures, can you explain what the model may be struggling with for these 2 classes? It might be that they look that a lot of the descriptions are very the same. One might be struggle to identify these 2 classes, reveal how about them. So that means that they're very similar, right? That they're the flute and the flute. Let me just so they were talking about this one. That the jute and the rise are very similar, or they have a lot of characteristics that are the same. So I'm gonna stop this. I'm gonna stop this video and go to the next one.